Good afternoon, everyone. Today I'm chatting with Gabriel René from Versus AI. Versus flagship product, Genius, is a neuromorphic computing platform that combines efficiency and adaptability to solve complex reasoning tasks. This innovative platform recently outperformed OpenAI's O1 preview model in a code breaking challenge, demonstrating superior speed, cost efficiency, and logical reasoning. In this interview, we'll explore the broader implications of AI models, the latest advancements in Genius, and the roadmap for Versus in the coming year. All right, everyone, enjoy the interview. Gabe, thanks so much for joining us today.
Hey, Steve. Great to be back.
Okay, so over the last few months, the narrative about the current state of AI has shifted. Bloomberg and many others are suggesting that the AI model companies' capabilities have plateaued. Now, actually, you predicted this would happen last year when we last chatted.
Yeah.
And I'm curious. I got to ask you, why are large language models hitting limits, and what's next for the industry?
Well, the limits are a function of the underlying algorithmic approach that all of the large language model companies are using. And the short version is it's an algorithm that requires millions of examples of any given data point. And so, with all the data points you can think of with respect to trying to understand relationships between data that come from downloading and trying to learn on the entire corpus of human text from the World Wide Web, you have to have this massive infrastructure, right? Lots of data, millions of examples, billions in some cases. That's why you need massive GPUs to process all of that data. And then, of course, now they've been talking about how much energy is required to process these models. And the expectation had been that they would continue to see these exponential gains. But what we predicted was that there would be certain limits to how much information you could extract out of all the data from the web. It's sort of like if you read every book in a given library the first time, you'd go from not knowing very much to knowing a lot. But then if you reread it a second time, you're not going to learn a whole lot more. And so now they're at the diminishing returns for exponential gains. And the problem they have is it costs 10 times more every time to make a bigger model to get a few percentage points. So we're really not seeing those exponentials. I predict that we've seen the end of the exponential era of this approach to AI. And the reason we predicted this was because their model essentially is this large correlational pattern matcher. And the work that Versus is doing it has more to do with these models that learn cause and effect instead of just correlations, that are small, that are light, that are adaptive, don't need a big GPU architecture, don't need nuclear plants to power them. And as a result, they can learn and adapt in real time. So, and the world, in terms of sensor based information, is a never ending pool of data. You and I don't have any problem processing that with 20 watts of power. And so we predicted that, just as their exponentials would start to end, our exponentials would just begin. And that's sort of the moment that we're at now.
All right, so it's been a while since we've had you on, and there's going to be people who I'm sure are now following the stock because you guys put out some exciting news this week, and there's a lot of activity in the stock, and with that comes a lot of eyeballs, people who are new to the story. So maybe you could walk them through the overall sort of, we could say, elevator pitch or just a general overview of the company for those who are completely new to the story.
Sure. The whole point of AI is essentially just using software to automate things, whether that's driving a car or completing some sort of this personal assistant that books a reservation for you, or ultimately operates the electrical grid, or automates some aspect of analysis for your data. And if you're an insurance company, um, all the way to humanoid robots, right? And so it's kind of the ultimate form of automation. And the idea is that all of the major players in the world now have moved on to the other thing that we predicted and we've been building towards, from chat bots that you talk to agents that do things for you. And so the autonomous agent is the new app. Like how you think of the smartphone application, now it's all about agents. This is what Microsoft is pushing. This is what Google is pushing. Salesforce has pivoted their entire company to agents. Agents are autonomous software that go and perform activities on your behalf. The real problem today is that the underlying model for reasoning, which is what you need if you're going to have a software program make decisions and take actions on your behalf, You better hope that they understand what they're doing so that they can execute the correct set of outcomes, goals, and activities that you want. Today's AI models are very poor at this form of reasoning because they just do statistical correlation. They can get pretty good, but not reliable enough. So what's needed is a new kind of approach to agents that allows them to do this sort of reasoning and planning. You can think of this as brain power for agents that is also wildly more efficient. So our approach comes out of neuroscience as opposed to computer science. As a result, we're designing a platform that allow these developers that want to build agents to use language models and vision models and robotic systems, but have a sort of executive function of the brain, the reasoning and planning power that brings it all together, that ensures reliable and accurate outputs in terms of the decision making and the action, but also is able to deliver that for an exponentially more efficient cost because our approach relies on these hyper efficient sort of approaches to modeling AI. So Versus is essentially developing a product called Genius that's designed to enable better, faster, cheaper approach to designing agents. And if you think about the notion of the last maybe 15 years, everyone wanted to make everything smart, smart cars, smartphones, smart cities. Now we've moved into the sort of intelligence. We want things to be intelligent. That's useful in terms of analysis and some prediction. The minute you want to move to agents, you have to really trust that they can execute on what they want. They better be very smart. And that's why we call our product Genius. It's about how to make sure that agents are smart enough to perform activities autonomously, whether that's in software programs or autonomous vehicles. This underlying algorithmic approach, we think, is the key missing ingredient and the enhancement needed to make agents widely adoptable, especially by enterprise, industrial, government, medical types of use cases and applications.
So I know a lot of the people that are following the story and reading your news releases know that you guys have the results coming out, or you guys are about to, I guess, perform in something that's called the Atari 100K Challenge. What is the Atari 100K Challenge, and why is it significant for Versus?
Well, one of the ways that we've tried to test AIs over the last few decades is to have them play certain kinds of games of skill, strategy that are rather complex. So it started back in the 90s with chess. Gary Kasparov was the global grand master. He lost to IBM's AI at the time, and this was Time magazine front cover type thing. Um, 2016, you had the latest approach to sort of deep learning, correlational pattern matching that underwrites large language models and chatbots and things like that today. And that beat Lee Sedol, who was the world champion at a game called Go, which is there's more moves than grains of sand on the planet, right? It's an extremely complex game, and so that these are supposed to be indicators of the intelligence capabilities of these systems. After that, the industry said, okay, well let's move on to things with that have sort of real world dynamics and physics and interactivity. And instead of just playing one sort of very difficult board game, what about sort of video games? And so Atari 100K has emerged as a sort of Olympics of AI testing against human capabilities. And that over the last several years, you have that model Alpha Go, which became Alpha Zero, which was the big winner in this sort of Atari test. It's a series of different Atari games from the 80s, Atari 2600, Pong and Frogger, and these types of games that some of you may remember. I certainly remember. And the challenge here is, can you get an AI model without giving it rules and without giving it explicit instructions, without programming it, um, data from the game, the ability to, in this case, 100K means 100,000 snapshots of the game, and have it that and the ability to understand that it needs to make the score go up, and it has to figure out how to play the game and win. The goal is to get above human level performance or superhuman level performance, and then do that across multiple different games. The challenge that we've accepted is to basically beat the underlying algorithms that Google uses for DeepMind for AlphaGo, or the transformer model that OpenAI and others have been using for large language models at Atari, but not beat them with 100,000 samples of the game, but with 90% less data and significantly less compute, not requiring a GPU, no NVIDIA clusters here required to do this. So beat them essentially perform at above human or above level performance, but with 90% less data, and with a model that's hundreds or thousands of times smaller. This would be a demonstration of the key capabilities that are needed for agents to be reliable, which are called reasoning and planning. This is the idea that models can reason about cause and effect. So if I go up and I hit the ball, will it go in this direction? And if it hits it, will it come back? So you have to plan into the future. You have to plan your moves. A game like Pong is actually analogous to something like driving a car if you're an autonomous agent. So these kinds of capabilities are really Atari is kind of a great test for showcasing this. Can you outperform humans? And then in this case, can you perform as well as the top models, but using a fraction of the data, a fraction of the compute, and at a fraction of the size? One other benefit that we expect to be able to demonstrate with some of these benchmarks very soon is that our models are also explainable. This is really important for governance and control of these kinds of systems, the ability to audit them, transparency about how they operate. Today's models are all giant black boxes that are just getting bigger and bigger, and you really can't tell what's going on inside of them. So our model is not only attempting to demonstrate that it's better, faster, cheaper, but also the explainability of it allows it to be transparent and auditable. So we can see what the agent is thinking, what it's predicting it should do before it does it. This allows us to put certain sort of controls and guardrails into the system that are really required for the kinds of enterprise industrial applications that we talked about.
So I want to take a step back here and maybe try to understand sort of Genius, what you guys have built versus the conventional AI that's out there. W- Would there be sort of an idea out there that perhaps the LLMs are better at language? Like if I wanted to write, say, I'm a grade 12 student and I want to write an essay to try to trick my teacher into thinking that I'm great at writing an essay at a grade 12 level, perhaps ChatGPT is going to be the better option for me than Genius. But Genius would make more sense if I just got a dentist appointment and I'm trying to fit that in my schedule. What really sort of what's the high level difference between Genius and Chat GPT, and why is it that we look at this and we obviously as retail investors we hear it and we just automatically want to think, okay, I'm going to compare the two, but are they actually pretty different?
Yes. So it would be a little like trying to compare a computer vision model to a large language model. One is looking out in the world, like the vision models that Tesla uses to drive. You can't talk to it, but it can navigate the world much better than the language model can. But right, so but the language model is quite useful to talk to. Here's the right way to think about where genius fits in the paradigm. Um, if you look at all of these different approaches to AI, they actually act as parts of the brain. But the key part that genius fills in is the part that's missing. So, for example, in your brain, you've got a visual cortex, right? You could think of this as computer vision models. You've got language comprehension, right? And that's exactly right. So it understands language, which is sort of linear text, as opposed to, say, vision, which needs to take in a bunch of information in real time. You got the motor cortex. This is what we're seeing in humanoid robotics, or the ability for a vehicle or drone to move around. And you've got other sort of sensory systems in there, language being the latest and most recent breakthrough, and certainly extremely impressive from a language understanding. But the real world has physics, there's spatial understanding. You have to understand cause and effect and context far beyond merely just language. And so the prefrontal cortex of the brain is what we call the executive functions, right? This is reasoning, planning, learning, regulation. It actually connects to all those other parts of the brain. It's like the quarterback on the field. That's what's missing. The ability to model the environment, model the scene, model the context, make the calls in real time, and adapt and change as you go. And so the vision model can remain the same. And in fact, developers can use computer vision models that are off the shelf, and they can use ChatGPT or language model along with Genius, but the language model is just the interface. Um, so the challenge today is everyone's trying to use the language models, which I would call kind of very good for content, where things do not need to be highly reliable or very accurate. And it's a bit like taking your chief marketing officer and trying to make them a CEO. You need the person who can see the whole field, really understands the operating context, and able is has the autonomy and ability to make those decisions because they can understand the context. Going back to your example with a student, you can use a large language model to try to pass that test, but the number one problem with these models is because they haven't learned cause and effect understanding of the real world, the things that the words reference, they hallucinate. And because they hallucinate, they always and constantly and continuously will make errors. So it will just fabricate things in that report, in that book report,
Yeah.
aren't true. So
Yep.
what you really want to do is use Genius to actually digest the book report, or to digest the book or the data, whatever the context is, and be able to model that in this very explicit, reliable causal model, not this just correlational model, that then the language model can go check. It's like it's acting like a reliable memory for the large language model to be able to get its facts straight. And now you especially want this if you have something that's trying to model medical data or financial information or doing forecasting or predictive analysis on anything that matters, including whether or not the car should stop or make a left turn or right turn. So 99% of the real world activities are missing this sort of capability, which you could think of as the executive functions of an agent. And Genius is the platform for allowing developers to build these types of models based on their data, not just based on public data. And they can still connect them and combine them with things like a language model or a vision model or some sort of motor robotics control model. But now you've got that quarterback on the field, that CEO in the seat, who knows how to basically read the changing dynamic environment or situation or ongoing shifts in the data and respond and react in a way that is frankly more efficient, more effective, and ultimately even explainable and auditable. And again, this is what companies are really looking for, and it's why we've only seen about 5% adoption from Gen AI in American companies today. Because whereas everyone is paying to test, none of it is reliable enough, given these hallucinations, to ship a product. And if you don't have reliability, you just have liability. And that's been the real barrier for these systems. So language models, great for language comprehension. You want real world understanding and reasoning. And when you need a model to be smarter, it needs to be Genius.
Okay. Now, obviously, uh, I imagine most of the investors watching this, they've got one thing on their mind, which is commercial implementation. I see that you guys have announced that you've got major names that are beta testing the platform, but how far out are we actually from seeing commercial implementation of the tech?
We expect to be sharing some commercial updates on traction from Genius in Q1.
Okay, perfect. You recently added Michael Bloom, the founder of Hedgeye, as the chair of the company. Why'd you add him?
Well, the company is really shifting from a research phase into product development, which was mostly 2024, and beta testing into a commercial phase. Michael has a really great background that spans, Silicon Valley, Wall Street, and international financial, sort of global finance relationships. And so we felt like Michael was the right fit as chair for this next phase of the company. And Jay Sammet, who's been amazing for us over the last couple years, really wanted to take a more active role given his background in global business development, his role as previously as vice chairman of Deloitte, and it's ultimately the kind of Deloitte and Accentures of the world that today sell products like Salesforce or Microsoft, Azure, that are always looking for companies that are building new software platforms that they can go sell to the Fortune 500 and Global 1000. And it's why, for example, not only do we have Jay, who's taking a more active role, and Michael taking the chairman seat, but Michael Wadden, who's our chief commercial officer, was a former Accenture director as well. So we're really well positioned, I think, for this next commercialization phase of the company in 2025. And I think Bloom's the right chair for the company as we kind of grow into our bigger shoes here.
Okay, so Versus announced this week a test called Mastermind, where your genius model competed against OpenAI's latest reasoning model called O1. What is Mastermind? What were the results? And why is this an important test?
So Mastermind is a code breaking game where since you have a series of different colors in sequence that represent the code, right? Red, orange, yellow, green, blue, but they're sort of scrambled. And the AI model in this case gets a chance to guess what it thinks those that string of colors is in the order that they're in. This can represent any sort of detection model. Um, and then it gets feedback from the system saying, well, you got one of them right, or you've got two of them right, but doesn't tell them which one. And then it's got to guess again and again and again. You got 10 tries. And if you fail within 10, then you lost the game. And if you win, you win. So in this case, O1 is OpenAI's latest reasoning model. This is their best model. Has spent billions of dollars to in research to get it to this point. It's considered the leading model in the world. And we wanted to test what Genius could do on something like Mastermind, which is not just about language-based comprehension, but it's about reasoning, sort of cause and effect relationships. You have a very limited time to be able to perform, and you've got to get it right within 10 steps, or it's game over. These reasoning models today, the way that they've enhanced these large language models is they've added this reasoning capability. I want you to think of this as the AI model now kind of asks itself 20 questions. It like thinks about it and tries to figure out a better answer within the pre-existing model, and tries to produce that. So it takes longer. It costs more, and it's a much slower process to try to get a slightly better answer. So we tested Genius against O1, and in a side-by-side test, and you can check the press release and you can see the results and watch the video on our website at versus.ai. You can see that we were able to, on 100 tests, get 100% of those tests we could complete within 10 moves, usually within six. OpenAI's O1 failed 29% of the time. So it got it right 71% of the time. We beat it. Average game, I think, for us was about 3.5 seconds, 5 minutes total for 100 games. There it was about 12 hours for them. And so we won with much better accuracy. We beat them 140 times faster, and it was 5,000 times cheaper. I can't remember the exact numbers, but for us, it was about 5 cents, and the cost to run Mastermind through 100 games was $243 or so. So significantly more expensive, wildly slower, and far from accurate. And this is just a quick example that I think is indicative of the kind of reasoning test where you have to be able to learn, get feedback in real time, adapt, change your answers. Many of the answers that came out of O1 kind of were random. Ours, as you could see, is really kind of thinking through each step, and at each step, considering what guesses it had previously made, and in a way anticipating what next guesses it might need to make. This is a wildly different approach because it's a different algorithm. As I mentioned before, our team comes out of neuroscience, and what we're doing is taking the processes that our team has discovered in the actual neuronal activity of cognitive processes in humans and in biological systems, and apply that to computing. Turns out that the rest of the world trying to build 5 gigawatt, $100 billion data centers, but your brain uses 20 watts of power. And Versus is not trying to just build one agent in one $100 billion data center and give everyone access and rent it to it, because we have these models that are light, that are small, that are fast, that are efficient, and are more accurate. They can run on 100 billion devices, right? Cameras and drones and robots and smartphones and laptops. So the test we did, for example, ran on a laptop versus OpenAI's O1 runs on God only knows how many GPUs. So this is a really significant milestone for us as a company. It's indicative of the kinds of results that we think Atari will further. We expect Atari to further represent in terms of really just a better, cheaper, faster alternative to the current state of the art. And it doesn't mean that we're not here to replace language models, but we are saying that businesses need something that's more reliable, more efficient, and even explainable in order to really deploy these. And so that's the sweet spot that we've been targeting. And Mastermind, I think, has been a very successful reflection of that.
Okay, Gabe, last question for you. If I'm an investor in the company or I'm watching the company and I'm trying to evaluate the story and figure out what's happening, what should I be looking out for over the next 12 months?
Well, we expect to be rolling out Genius over the next couple of quarters. So some early traction here in Q1. We expect some commercial partnerships and announcements, some new noteworthy beta partners that we're excited to share. with the public, and then the full release of the platform, which will allow developers to run with this model. And at that point, you're starting to see sort of recurring revenue growth throughout the course of the year. I think there'll also be a handful of other benchmark tests that we're going to be going after throughout the year, with the goal of not only beating some of the state of the art language models, but actually the state of the art robotics models, and even ultimately the multi-agent stuff. Because as I mentioned, we're not trying to build this sort of single agent architecture that everyone accesses. We're building this genius platform to allow millions of developers to build applications that power hundreds of billions of real world scenarios and devices. And that means that you need to have these AI agents that are light, that are at the edge, and that can compute hyper efficiently while being able to be both highly reliable and accurate and adaptive. So my hopes for the year is that we really enter the world stage as the missing ingredient for making AIs reliable, effective, and more efficient.
Well, Gabe, thanks so much for hopping on. I think that this is one of the most exciting stories we have here in the Canadian junior markets, and hopefully we can catch up in Q1 and you can update us on how everything's coming along.
Yeah, we'll be excited to share some really amazing updates then, and have a happy holidays, Steve.
All right, everybody, thank you for watching. If you enjoyed this interview, please smash that like button, subscribe, and ring that notification bell. All right, everybody, thanks for watching.